Buenos dias! Welcome back to the course on Design of Information Systems. What we have done previously was basically we have had a walkthrough the basic diagrams of UML that are applied in a software development process, and the diagrams that we have encountered so far in a very short way were the class diagram, the use case diagram, the object diagram, the state chart diagram, interaction diagrams, namely the sequence and the communication diagram, and we have looked at activity diagrams. These diagrams were enriched and made precise by expressions written in the object constraint language, and I have applied OCL in various forms in these examples, and I have explained the use of the diagrams and partly the use of OCL with the tool use. Let us look at the central diagram, namely the class diagram. Again here, I will come back to this point in a minute. These were the topics that we have discussed so far. We have looked at the concepts that were mentioned in this diagram, that were used in this diagram. We have seen classes, attributes, operations, parameters, return types. We have seen one collection kind of the various collection kinds. Namely, we have seen the set. Here was the set, the OCL set. We have shortly sketched how associations were used in that diagram, namely binary association and association class, which is an association with attributes. We have talked about reflexive associations, and I've mentioned the composition as a form of association. Composition is always indicated with a black diamond. What I have not explained so far is that there is another form of part-whole relationship, namely the aggregation, and composition and aggregation are explained here in a more precise way. And we have talked about the concept of a role, of the concept of multiplicity, and how roles are used for navigation from one object to other object. These were all explained in this class diagram. So again, we have here the class profile. The class diagram is about a social network. We have the class profile with various attributes, first name, last name, username, and certain things can happen to a profile. In a social network. A profile must be initialized. Then the profile can invite other profiles. If an invitation has been expressed to the current profile, the invitation can be accepted. The invitation can be declined. Certain postings can be made by the profile, and for a given posting, certain comments can be made. We have here the central association class, friendship, binary association, a binary association class with the two roles, inviter and invitee. And for example, we see another binary association here, the association interest between profile and subject, in order that a profile or a person standing behind the profile can express interest in certain subjects. Let us shortly come to the point here, the aggregation and the composition. Both are part-whole relationships. So the part-whole relationship in this example here, the postings are a part of the profile. This is the part-whole relationship. The profile plays the role of the whole and the posting plays the role of the part. So on the black diamond side there is always the whole. Composition and aggregation are part-whole relationships. They are acyclic on the object level. So no part can be a part of itself. A composition, as indicated with the black diamond, a composition denotes an exclusive, a strong binding between the whole and the part. The part exclusively belongs to the whole. And that means on the whole side, there is either the multiplicity 1 or the other option, there can be the multiplicity 0, ... We will see more examples for composition and aggregation and for part-whole relationships later. This will be a special discussion point. Here we are in a position where I just want to give an overview. What are the key points of part-whole relationships and what is the distinction between composition and aggregation? Aggregation is a shareable part-whole relationship and it has a weak binding. So a part can be a part of not only one whole but of many wholes. And we see an example for this over here. We see on the one hand we see in a chessboard, chess game class diagram, we see here composition, the black diamond, and we see here aggregation, the white diamond. What we also see here in this example is another concept that is very important in connection with class diagrams and that was not mentioned before because it is not occurring here in this example. It is the concept of a generalization. With the concept of the generalization, one can express that particular objects are special cases of other objects, or viewed the other way around, that particular objects are more general, are a generalization of other objects. So the concept is called generalization, but you can also, generalization is looking at this relationship from the bottom here of the diagram and looking into the more general direction, but you can also think of it as specialization. Then you start in the upper part and look into the more specialized parts. It is typical that generalization relationships are displayed in such a way that the more general part is placed above the more special part, but this is not a formal requirement. So the generalization that we see here, I said it's a kind of chessboard application, and the generalization that we see here is we have certain characters in a chess game, and the characters are of a special kind. Namely, the characters, they can be a character can be a pawn, it can be a knight, it can be a rook, it can be a bishop, it can be a king, and it can be a queen. So these 6 classes are specializations of the class character, or as I said in other word rounds, the class character is a generalization of each of the 6 classes representing characters, representing figures in a chess game. Another option in a class diagram occurs here, namely you can have enumeration types, and I've defined here an enumeration called color enumeration, which is black and white, and each character object is attributed with the attribute color, which is of type color enumeration, and well, it's the option that you can indicate whether you have a black knight or a white king and so on. This attribute, color, which sits in the general class, is inherited to each of the specialized classes. So this attribute is available in each of the specialized classes. And this makes highly sense in this example. We have a player here, and a player owns up to 8 pawns, up to 2 knights, up to 2 rooks, up to 2 bishops. A player owns exactly 1 king, and the player owns 1 queen, or it may be the case that the player has no queens at all. So the exclusive ownership during a game of these single characters is indicated by this composition relationship. And in addition, what we have seen not so clearly are uses of multiplicities here. In the previous class diagram, mainly the multiplicity star was used, which is basically an unrestricted multiplicity. Only at one position we had here the multiplicity 1, which indicates that posting belongs to exactly 1 poster. Here we have a wider range of multiplicities, and games are a typical case where you use multiplicities to indicate the configuration in a game. And this is the way it is done here, to indicate that a player owns exactly 1 king, and a player owns up to 8 pawns. So any number of pawns is acceptable, which is between 0 and 8 for a player. That's a typical use of the multiplicities here. This is a black diamond expressing the exclusive ownership during a game of a particular character for a player. I have used here during the game. During the game, there are parts of the game. There are 2 players are parts of the game. This is a second part-whole relationship, game player. A game consists of exactly 2 players, and 1 player can be part of many games. This is due to the fact that we can imagine we not only have 1 game object, but we have a number of game objects, and when the same player participates in different games, then we need this multiplicity 1 ... star here. But in order to indicate that a player is part of the game, we have used here the white diamond, the aggregation part-whole relationship. By using this white diamond, by using the aggregation relationship, one player can be parts of many games where, in contrast, during a game, each single figure is associated with exactly one player, as you see in the one multiplicity here on the lower side of the diagram. So these are the concepts that we have not seen before and that I have not been discussing before, namely the aggregation in addition to the composition, which we have seen before, and the generalization relationship, which did not appear in the social network example. One remark about the OCL collection kinds. We have seen the set collection kind over here. Each profile has a set of friends, which is indicated here by this operation, which sits as an operation in the second compartment of the profile rectangle and is typed as a set profile. Apart from the collection kind set, there are other collection kinds, namely a set and a bag. And there is also a generalization using this concept. There's a generalization of set, bag, and sequence, which is called collection. So collection is and now apart from, I have used in connection with generalization, I've spoken about a specialized class and the more general class, but there's also another term that is used for this situation, namely I very frequently will speak about the subclass pawn with respect to the superclass character. So subclass and superclass are also, these notions are also used in connection with generalization. And so what I've said before, that collection is a generalization, for example, of set, and collection is a generalization of bag, is reflected here in the term we have a superclass collection that is a generalization of set and a generalization of bag. So far so good. This was about the concepts in class diagrams, and now we have seen at least the concepts that are mentioned in this slide.